Talking about motor replacements. In various industries and applications, motor plays a vital role in powering machinery and equipment. Over time, motors can experience wear and tear, leading to decreased performance and efficiency. In such cases, motor replacements become necessary to ensure uninterrupted operations. This article delves into the significance of motor replacements, exploring the reasons for replacement, the types of motor commonly replacement, considerations for selecting replacement motor, and the benefits of opting for new motors. By understanding these aspects, individuals and business can make informed decisions regarding motors replacements and maintain optimal performance in their operations. There are a few reasons for motor replacement. Several reasons why motor replacements may be required. First and foremost is the aging factor. Motor, like any mechanical device, have a finite lifespan. After years of continuous operation, the efficiency and performance of motor decline, resulting in increased energy consumption, decreased output, and potential breakdowns. To avoid costly repairs and production downtime, replacing aged motors become crucial. Another reason for motor replacement is technological advancements. With constant innovation, new motor models often offer improved efficiency, enhanced performance, and additional features that can significantly benefit operations. Upgrading to the new motor technology can lead to reduced energy consumption, increased productivity, and improved reliability. Additionally, motor failures due to electrical or mechanical faults may necessitate replacements. Excessive heat, voltage fluctuation, bearing wear, or mechanical damage can render a motor irreparable. In such cases, replacing the motor becomes the most valuable solution. Types of motor commonly replaced. Different industry employ various types of motor depending on their specific needs and applications. Some commonly replaced motor includes AC induction motor. These motors are widely used in industrial application. They are known for their robustness and longevity. However, due to aging or performance issues, AC induction motors often require replacements. DC motors, these motors find application in automotive, robotic, and industrial machinery. Over time, the brushes, commutators, and windings in DC motors can wear out, leading to decreased performance. Replacing these components or the entire motor may be necessary. Servo motors. These high precision motors are crucial in applications requiring accurate control, such as robotics, CNC machine, and automation system. Technological advancement in servo motor technology may prompt replacements to take advantage of improved performance, higher precision, and faster response times. Considerations for selecting replacement motors. When replacing a motor, several factors should be ensure the best fit for the application. Power requirements determine the required power output and torque for the specific application to select a replacement motor with appropriate specification. Motor type. Evaluate the advantage and limitations of different motor types such as AC induction, DC or servo motors based on the application's demands. Efficiency. Opt for motors with higher energy efficiency ratings as they can result in significant cost saving in the long run. Physical compatibility. Consider the physical dimensions, mounting requirements, and shaft specification to ensure a seamless integration of the replacement motor into the existing system. Environmental considerations assesses the operating environment including temperature, humidity, and potential exposure to dust, chemicals, or moisture, and choose a motor that can withstand these conditions. Benefits of opting for new motors. Investing in motor replacements with newer models offer several advantages. Improved efficiency. New motor technology often feature higher energy efficiency ratings leading to reduced energy consumption and lower operating costs. Enhanced performance. Upgraded motors may provide improved speed control, increased torque, higher precision, and fast response times, thereby enhancing overall productivity and operational effectiveness. Reliability and durability. New motors are less likely to experience unexpected breakdowns and failures, reducing production downtime and maintenance costs.